Waste can be a resource and not a problem. This is the approach that inspires today's treatment methodologies. The goal to be achieved is to maximize recycling in terms of both secondary materials and energy recovery, as well as to minimize the environmental impact of processing plants. In this perspective, disposal facilities are now virtuously evolving into integrated systems of treatment. The FullCircle is an integrated system of treatment aimed at making the best possible use of the waste generated by both citizens' consumption and production systems. It's a flexible system capable of either adapting to a future where wise political and industrial choices will lead to waste quantity reduction and quality upgrading, or effectively tackling the existing problems. The principle from which our system draws inspiration is the so-called rule of the 3 R's: reduce, reuse, recycle. Rejects that are considered a problem are, on the contrary, the resource that is the substance of our system, the purpose of which is to implement the 3rd R, recycle. Waste fractions from the source, separated collections such as glass, metals, paper, plastic, can be reintroduced as secondary materials into their respective production cycles. Mixed waste that didn't go through a source-separated collection is bound to mechanical biological treatment plants, where it's separated through mechanical sorting processes into different fractions. Recyclable materials, such as metals and plastic. Stabilized organic fraction. Combustible fraction. 1 ton of RDF has the same energy content of approximately 3 oil barrels. Energy recovery is a decisive factor for both the economic result and the environmental protection connected with conservation of the conventional energy resources. However, being RDF a non-conventional fuel, it can be used only in specially provided plants, capable of guaranteeing the total absence of danger for public health and the environment. All available processes and technologies have been evaluated in order to select the most qualified thermal treatment to fit and complete the FullCircle. The fundamental criteria that led to the selection were the effectively proven safety and reliability with the purpose of ensuring a fully sustainable environment, mainly concerning the most dangerous components like dioxins. Based on European regulations currently in force for the incineration plants, municipal waste burning in the open air, which means uncontrolled, may generate dioxins concentration in the fumes up to 4,000 times higher than the accepted limit, while the gasification technology allows concentrations approximately 2,000 times lower, on the verge of non-measurability. Gasification is a molecular dissociation process induced by temperature. Materials in their solid state are subjected to physical and chemical transformation processes in order to sort out the combustible fraction from the inert fraction to reach a condition more suitable for energy production, gas. By way of example, bear in mind the difference between a power plant fed by coal, solid, and methane, gaseous. Even the most resistant organic compounds decompose at high temperatures, completing the transformation into gas of all the combustible fraction without constituents in a liquid or steam condition, the tar. The process products are gas and vitrified inert matter. Regardless of the starting materials, the combustible gas, syngas, at a macroscopic level consists of hydrogen, carbon monoxide, carbon dioxide, nitrogen, water. The main reactions occurring in the gasifying section are exothermic formation of carbon monoxide and carbon dioxide fission endothermic reaction, and in an atmosphere enriched with water vapor, shift and water gas endothermic reactions. Gasification plants represent a cutting-edge solution offering fully industrial applications. In order to evaluate the state-of-the-art in the thermal treatment of waste, the Japanese experience was examined. The geographical and demographic conditions have heavily obstructed land filling and also forced plant's implementation in populated areas, which is why environmental issues are a very real concern. In addition, Japan is a supporter of the Kyoto Protocol and has identified one of the greenhouse effect reduction factors in energy production from waste. In this context, the development of waste treatment systems has been strongly stimulated, and the country's wealth and technological level have allowed extensive research and development activities. The most suitable process to achieve this goal has been identified in gasification. Since the year 2000, in Japan, orders for gasification plants have overcome orders for incineration plants. Presently, gasification process plants in operation or under construction number 107. Among the thermal treatment plants ordered in the year 2006, gasifiers' percentage reached 75%. Fukuyama is the sixth plant built applying the technology of the Japanese group JFE. The treatment capacity of the plant is 314 tons per day of RDF, and the electrical power generated is 20 megawatts. The RDF is fed to the gasifying and melting reactor. The gas obtained is utilized in a boiler to generate steam that's used by a steam turbine for the production of electrical power. The vitrified slag is taken out from the bottom of the reactor. It can be used for road construction or for other applications in the building industry. After the combustion, the gas flows through an economizer to complete the energy recovery, and then is sent to the purification plant. Dust and ashes are collected and recycled back to the gasifying and melting reactor. JFE, gasifying and melting reactor, could be divided into three zones. Zone 1, for gas treatment in high temperature, reducing atmosphere. Zone 2, for fluidized gasifying and pyrolysis. Zone 3, for high temperature combustion and reduction melting. 3 levels of air injection are placed in the reactor to maintain the appropriate temperatures for the gasifying process. The molten slag flows out from the bottom of the reactor to a water bath, where it instantly cools down, producing a vitrified and granulated material. A transportation system collects the granulate from the bath, dividing possible metals from the minerals. Finally, the materials are stored in 2 dedicated areas. The minerals, shaped as sand, will be used as construction materials. The metals will be melted and recycled. From the rigorous controls of the Japanese authorities, it's clear that the gasifying process is extremely effective against dioxins formation. The electrical power produced is sold to the grid and used to feed the entire facility, including the RDF production plant. A computerized control system runs the entire plant, monitoring and controlling each step of the process in real time, making it safe and reliable. It was logical that the first implementation of the FullCircle system should be realized in Rome, in the city of environmental industries of Malagrotta, where a mechanical biological treatment facility for mixed waste is already in operation, producing a quantity of RDF equal to 30 to 35% of the processed waste. The construction of the gasifier is subdivided into 2 phases. The first one will be dedicated to the implementation of 1 gasification line and a steam cycle for energy production. During the second phase, 2 additional lines, one of which in standby, and a combined cycle with a gas turbine will be implemented. This will be the first realization of its kind in the world. Electromechanical works were started on February 15, 2007, and plant tests of the first phase began a few days ago. Because of the technological solutions that have been adopted, the Malagrotta gasifier will be a preeminent reference point worldwide. It will be fitted with a synthesis gas scrubbing section and will be equipped with a hydrogen production unit for fuel use. A hydrogen filling station open to the public will be installed near the biomethane station already present at Malagrotta. Again, this is the first case in the world of cars fueling with hydrogen produced from waste. The power station is divided into 4 areas and is greatly integrated into the industrial and operational context that already exists at Malagrotta. Area A, where gas is produced and scrubbed. Area B, next to the biogas turbines already in operation, where electric power is generated. Area C, dedicated to oxygen production needed by the process, is placed in a barycentric position with respect to the premises where all general utilities have been concentrated. Area D, where the percolate extracted from the landfill is purified and transformed into industrial water necessary for the site. Once more, a problem which is transformed into a resource. The data from the emissions monitoring systems will be available on the web in real time and will be freely accessible by the public. A second FullCircle project has been submitted to the city of Albano by AMA, Acea and Pontina Ambiente. The plant is expected to be located in the industrial area of Cecchina at Roncigliano, next to the existing plant for the mechanical biological treatment of mixed municipal solid waste serving the Castelli Romani area. FullCircle, from RDF to gas to energy.